Cool. So let's. It's a minute before 5. Let's start. Welcome back to everyone. Let's start with study unit 7, and hopefully we can finish that today. That the next one is study unit 8 that we can start. So let's look at study unit 7, and I think the important one about study unit 7, when we're looking at the sample distribution of the mean and proportions, the important thing is that for the distribution of the mean, we can basically have two ways of calculating that. So it is by all that we're going to use is Z. So when we know that this population standard deviation is known, we will use the Z. When the population standard deviation is unknown, we will use the T value. So that is on the distribution of the mean. Then on that one, depending on if the standard deviation is known or unknown, we will use the Z or the T. And for the proportions, we will always use the Z table. So I just think that is important. So the only time that you will use a T is when the standard deviation or the population standard deviation is unknown. Okay, so let's work through a few examples. And hopefully it's not too difficult. Most of these ones you will see that what we need to do is basically we would need to work out firstly the Z value. So that is the first thing that we will need to work out. And then normally what we will need to work out is on that curve, wherever that Z is, we will need to say what's the probability. So if it is sitting there, we will need to say the probability of that Z being bigger than. Okay, but at the moment we don't know. So first thing, we need to calculate the Z, and then we need to use that Z and go to the table. So here they tell us we're going to use Z table. So you don't even need to worry if it is population or standard, population or sample, but they do tell us it's a normal population. So basically then we're going to work out the Z. So also remember the formula for the Z when we know that there is a sample involved, that is your formula. Okay, so let's just make that a bit better. That is the N. Okay, so basically from there, let me just get some more space to write. We know the X, they tell us it must be bigger than 1050. They tell us the mean is 1000. So that already at the top will be 50. So I'm just skipping, or not skipping, I'm just making it easier for myself. Then at the bottom we have a standard deviation divided by the square root of n. So the square root of n is, the square root of 16 is 4. So 200 divided by 4 will also give me 50. So 50 divided by 50 is 1. So I need to get what is the probability that Z is bigger than 1? Okay, so that is what I need to find out. So then if I'm using my diagram, I know from last week, we know that is 0. So 1 is going to sit somewhere there. So I need to get that probability. So now I know that if this yellow part is 0.5, the part that I'm looking for, the green part, will be smaller than 0.5. So by then I know that can't be an answer. I know that can't be an answer. And I know that can't be the answer. So then I'm basically sitting with one of two that I need to basically work with. Okay, so now I would go to the Z table. The Z table for 1 tells me that this part is equal to 0.8. Let me just get it right. 8413. Okay, so that one. But because I'm looking for the smaller part, I need to say 1 minus that, and that will then give me 1 minus 0.8413, gives me the 0.1587, which is option 2. Okay, but to make it the process, we first need to get a Z. Then we will need to, with that Z, nearly go to the Z table, but I use my own drawing just to make sure what I need to get. And then from the Z table, depending on which side you need it to get, you need to decide if you take the value or if you say 1 minus that value to get to a smaller area. Okay, so first step, get the Z. Second step, use that Z to go and find the probability. Okay, and that will be for study unit 7, that will be the whole process every time. Get a Z, go to the table, get the probability. I think the one difference is then when we know it is unknown or known the standard deviation. Okay, so let's go into the next one. So let's see what they are asking here. A normal distributed population has a mean of that, standard deviation, that was standard error. Okay, so this time they're asking us to work out the standard error. So when we have this Z that we need to work out, this part, the standard deviation divided by n, this is what we call the standard error. Okay, so this is what we call the standard error. So for this one, we don't need to work out the Z. We just need to work out the standard error. And I think that is quite important important again to see what we need to get. So need to work out the standard errors. So we look at what is the standard deviation. Standard deviation is 1.2, and we need to divide by the square root of n. So n is 100. So the square root of 100 will be equal to 10. So basically, wait, that is not 1.2, that is 12. So basically 12 divided by 10 will give me the answer, which is 1.2, which is option 3. The scary thing with this one is if you look at it, we luckily they didn't give us, so they give us the mean, but they don't give us a x. So because they don't give us a x, we won't fall into the trap to calculate a z. Okay, so because sometimes they give you all the information and one is so used to working out the z that one misread sometimes what they are asking us. Okay, so I just think that is very important, that standard error, we're just looking at that bottom part of a formula. Okay. Happy with those two so long? Anything that you want to ask from your side? Otherwise, we can just continue. Okay, so let's go on. And let me just open my chat as well. Cool. Okay, so the next question. So which one is incorrect? Okay, so now they basically combining definition with some extra work that you need to calculate. Okay, so let's see. The sampling distribution of a mean will have the mean as the original population from which the samples will drawn. Sure. Now one needs to go into probably your textbook and things like that, but let's the sampling distribution of a mean will have a mean as the original population from which the samples were drawn. That one is correct. The standard deviation of a sampling distribution of a mean is also called the standard error. That one is correct. That is what we basically did there. When the population mean is that, the population standard deviation and that, the standard error is. Okay, so now this one we need to calculate. So remember the standard error is that formula. So 25, what's it divided by 8? That I need a calculator for. 25 divided by 8 is 3.125. Okay. Okay, so that one is also correct. A confidence interval is an estimate for which there is a specified degree of certainty that the population parameter will be in the interval. Yes, but that is only in chapter 8 that we actually do that, because that's for confidence intervals. So that is, we use the t-distribution for the statistical inference of the population mean when the population standard deviation is known. Okay, so that one is wrong because we use the t-distribution when the standard deviation is unknown. Okay. So that is just important. So, but that was interesting that they've thrown in a question that okay, no, it is, so what I'm using is there was in part of your study material that's on my UNISA. This is one of the documents in there just with extra examples. So I'm nearly using that as just a basis to go through a few examples. Okay, cool. If you don't find it, let me know and I'll share the whole document on the WhatsApp group as well. So if you don't find it, just let me know on the WhatsApp group and I'll share it there as well. Okay, so what I've done is I've picked a few ones that just showcases nearly the different ways that they can ask it in their exam. Okay, so those three were quite different. It was calculating Z, using that Z to get to the population, or sorry, the probability. This one was calculating the standard error, so you still need to know what the standard error is. And this one was more a definition, but including a bit of a standard deviation. Okay, so let's look at the next one. So when they started introducing something, the standard deviation is known or unknown, then I nearly start reading with much more care the next set of questions. So, and again, I know it's difficult in the exam because it's online, so you can't really highlight certain things. But what I then would do is nearly to look at, okay, so we're talking population standard deviation. So then I know it is going to be the Z and not a T. Okay, so they tell me it's population standard deviation. So I would nearly, on the paper that you can work out some of your answers and things, that your scribble paper while you're writing, I would nearly then automatically write it down as Z, so that you don't later on start to wonder. Okay, so then with this, they ask us, what is the probability that a simple random sample of 25 items will have a mean that is between 79 and 85? Okay, so that now tells me that, just as a quick, I'm gonna get two answers and I will need to see what is the probability between them. Okay, so this one is nearly the most difficult that you will get, because now you need to work out that one, you need to work out that one, the two Z's, and then you need to subtract the one probability from the other one. Okay, so let's work out the biggest one first. So the 85. So Z is 85 minus the mean of 80. divided by standard deviation of 10 divided by the square root of that. So we have 85, sorry, we have 5 divided by 10 divided by 2.5. So I'm just doing 10 divided by 5, sorry. So the 1z is going to be 2.5. So let's see the other z. -79 minus 85, which I am again just shows you how easily one can make a mistake. So that will stay the same. So 10 divided by 5, so that will stay the same. So we have -1 divided by 2, which is equal to minus 0.5. Okay, so basically we need to get the probability of that part. So what I would do is I would get the probability of z smaller than 2.5. And let me just color that in with yellow on this. So I would get that probability. And then I would say minus the probability of z smaller than 0.5. So let's use another color for that. So that is that part. So if I subtract those two, then I will get the portion that is left. So that will be my answer that I need. Okay, so probability of z smaller than 2.5. So I need to go to my z table. So probability of z smaller than 2.5 is 0.9938, and just watch. So there it is, minus the probability of 0.5, which is 0.6915. I am surprised that that number is also not in here. I must say I am surprised, but there is the opposite. So if you looked at the negative table, that is what you would have gotten. So that is, if you looked at the negative table for z minus 0.5, you would have gotten that. So then if I subtract those two, 9938 minus 0.6915, I do get the answer of 0.3023. So let's see if that is an option. No. Okay, so let's quickly see if I made a mistake. Yes, I did. Okay, so I needed to get that. So I needed to actually use that, sorry. And that is how one can easily make the mistake. I was talking about the one that I need to use, but I didn't. So I needed to look at the Z negative table. I looked at the positive table. So if I looked at the negative table, that is what I would have gotten. So I was actually telling you guys what to do and made the same mistake. Okay, so I needed to look because you would have seen I've drawn in a negative at a later stage. So I need to look at the negative 0.5, which will give me then that area as the 0.3085. So if I say 0.9938 minus 0.3085, I will get an answer of 0.6853. Okay, which then is option 3 as your correct answer. And just look at that one. That is very, if you just quickly looked at it, you can easily make the mistake of choosing that as well. So it was only the last two that swapped around. So again, if you're in the exam and quickly getting the answers, it's very easy to swap those two around. Okay. So basically what we need to do, and again for me this is the most difficult one that you will get. So you will need to first work out the first Z for the 85, and that is 2.5. You will get for that 2.5, you will get a probability. You will work out the second Z for the 79, that 79, and just remember it is minus 0.5. So because it's minus 0.5, you need to look at the minus table. So for that one, the probability was 0.3085, and then we are looking for the probability between the two. So we take the total probability that we had minus that to give us the part that's left, and that would have given us the answer. Okay, do you guys quickly want to ask a question on that one? I think that is, again, for me, this will be the most difficult one that you will get. Okay, so let's go to the next one, because hopefully now we're getting into some of the... Okay, cool. And does it make a bit more sense now as well, I hope? So let's go into the next question. The amount of time it takes to complete a final examination is normally distributed with a mean of 75 minutes and a standard deviation of 8 minutes. If students are randomly sampled, what is the probability that the sample mean of a sampled students exceeds 76 minutes? Okay. Okay, this is quite interesting. So I nearly want to say amount detected component is normally distributed. Do we know if this is a standard deviation is known or is it unknown? And does it matter in this instance if it's known or unknown? And they do tell us it is normally distributed. Okay, so they tell us it is normally distributed. I think that is also important. With a mean of 75 minutes. Okay, so before I just start writing, let's just write everything down. Okay, so we need to work out what is the sample mean of exceed 70. So we need to work out the z when z is bigger than the 76. The standard deviation was 8 minutes. N was 64. Okay, so this is a strange one. So Z bigger than 1 over 1, which is just bigger than, okay, which is equal to 1. So this is, so we're looking for Z bigger than 1. Okay, so just again, that is 0, somewhere there is 1. We're looking for that area. So basically can't be that because it needs to be smaller than 0.5, and then automatically I pick up this one where it's 0.1587, 0.1578. So I want to nearly say it is one of those two. Okay, but we basically go to the Z table. So the Z table will basically give us this value. So we'll get that value and we will say 1 minus that value, and that will be our answer that we will get. Okay, so we'll get that value. So we'll get that value. We'll say 1 minus it, and then we will get the answer that we are looking for. So let's quickly check on the Z table. Z equal to 1 is 0.8413. So it was actually that one that we could have used. So 1 minus 0.8413 will give me I'll switch on the calculator. 1 minus 0.8413. So the answer is 0.1587. Okay, which is that. So just make sure if seems like it can be that in the book they give you option 3 as for answered. So when you go through the book, also just make sure. Also, if you go through the book and there's an answer that you feel is wrong and you're not getting to that answer that they've explained, also please post on the WhatsApp group that you, and you can just take a picture and say, this is the question that you've seen, you're not getting the answer, just check if there's something wrong. Because like I've done now a few times with these sessions, there are mistakes in that book with the examples. So that we just, if there is something that you pick up that you feel you're not getting the same answer, don't always think it's you that made a mistake. It can be that there's a mistake in the book as well. Okay, so that basically covers the questions on when we're talking about the mean distribution. Now we will basically look at the next one, which is the proportions. So let's look at the proportion, and I just need to, I can't remember the the formulas for this always, so let me just write the proportion formula down. Again, we're looking at the Z value. So I'm just writing it down, and I will probably copy it when I need to look at the other questions as well. Okay, so this is a bit more difficult, this equation. So let's look at the question. So in a binomial experiment, okay, that's quite interesting, with a sample n and the sample proportion of p equal to that, the standard error for proportion is. Okay, so first, like we did in this one, the bottom part was the standard error. It's exactly the same when we deal with proportion. So this part is equal to your standard error. So you can say, well, I need to work out the standard error. So the other thing that we have, and you must check in your study guide for that one, is that there is another formula, because this now is interesting. So we're looking at P, and they don't give us anything else. So I would assume that we can just do this as well. Divided by n, that is 300. Square root of that. So let me just, now I need to get the calculator again. 0.5 times 0.5 divided by 300. The square root of that gives me 0.028. Okay, so let's 0.0283. Okay, so that one is, I just want to check 0,2. No. Okay, so that one is the closest to that. So basically standard deviation or the standard error, like in the one with the mean, it's basically looking at the part that you divide by. So the same for the proportion, you're looking at that part, and then it is you've got the probability of a sample proportion, which is 0.5. So 0.5, 1 minus 0.5 is also 0.5. So 0.5 times 0.5 divided by 300, and the square root of that whole thing will give you the sample, the standard error of a proportion. So just think again, interesting that we've now started that with even the first question. Normally we'll start with the others first and then throw in the standard error one. Again, you will probably not get both of them. If you get one of them in the exam, you won't get both. So again, I think it's nearly important just to know how to do it. And if you get one, you will only get one of the standard errors. You won't get to work out both standard errors for the mean and for the proportion. Okay, so now you can see it nearly follows the other question set as well. So they give you a bit of information. So let's look at what they give us. They tell us we've got a random sample, binomial population with a population proportion. So that they tell us as well. And the number of observed cases is 96. Okay, so the first one that we need to see that is, and we look for something that is incorrect. So the first one, the sample proportion. So the sample proportion is the 96 divided by 400. So 96 divided by 400 is 0.24. Okay, so that is unfortunately correct. So we're not done yet. Okay, the standard error. So remember the standard error is that. So let's quickly see. 0.2 times 1 minus 0.2 is 0.8 divided by 400 and the square root of that. So let's just see. So that is 0.2 times 0.8 is 0.16 divided by 400 is 0.0004. If we take the square root of that, it is equal to 0.02. Okay, so correct. Okay, then to work out the test statistic. So the test statistic is Z is equal to, where was that? The sample proportion minus the other one. So let's quickly see. The sample one was 0.24 minus 0.2 divided by the standard error, which we have worked out already. Okay, calculate the time again. 0.24 minus 0.2 is equal to 0.04 divided by 0.2 gives me 0.2. Okay, that is weird. Okay, so is that one then wrong? Because that is what we needed to get. Let's just quickly check the other one. So if I needed to work out what is the probability of that bigger, so sure, this looks weird. So that is 2.4 minus that. There I made a mistake, sorry. I thought something is not. That just looked too small. Okay, so let's just check again. That should have been 0.02. 0.02. Okay, so that would give me an answer of 2, which still makes it wrong. So let's just check if there's not something weird in that one. So probability that the sample proportion is bigger than 0.24. So we've worked it out there. So we basically want to get the probability of that small area. So again, we use the Z table. So we will go to the Z table where Z is bigger than 2. Okay, so let me just write that in something else. So where Z is bigger than 2. Okay, so let's quickly check the Z table. 0.9772. So let's just say 1 minus 0.9772. So that area is 0.9772. To get that portion, then it's 1 minus that, which is 0.0228. So that one is correct. And then the last one was, this is a case of sampling distribution for proportion. Yes, that is what they are talking about here. So that's actually a stupid option to have, but that is true. So just by 0.2, that one was the wrong one. Yeah. So this again is, there's a lot of work going into this question, and it wasn't really that there's nearly an easy way of getting to the incorrect one. You nearly need to work through every one to get to the incorrect one. Okay, but this nearly tested everything you need to know about the sample distribution of a proportion. It tested how you need to work out the Z. It tested that you know what the standard error is. It tested you how to work out the sample proportion, and then it tested you to look at the Z table too. So basically, if you can do those 4, then you actually know everything that you need to know about the sampling distribution of a proportion. because that is everything that we have tested in this one question. Okay, so let's see what else they ask us. So again, is a standard error one. So they tell us the population proportion. So again, it is, so luckily after this session, you will exactly know how to calculate the standard error. So 0.68 times 1 minus that is 0.32 divided by 20 and the square root of that. So 0.68 times 0.32 gives me 0.218. That divided by 20 gives me 0.0109. So automatically look at that, there was that option, but I need to take the square root of that, which gives me 0.1043, okay, which is that option. So again, just to show you that if you didn't do the square root part, there was an option for you, which again, it's scary that it is there, but yeah. So again, just to, and if, okay, so let's make it more, a bit more scary. So if I say 0.68 times 0.32, it would have, I would have gotten the 0.2196 divided by the 20 gives me that, and if I square root that, it gives me my final answer. So there could have been that, again, in my exam, you're rushing through it and you're not focusing 100%, and you do see options cropping up or popping up that is sitting in the paper, and even though you haven't went with all the steps, you nearly start seeing all of these other options, and then you start wondering if you are doing the right thing. So just keep in mind that what we need to get to. Okay. So let's look at another problem. So again, they give us n is equal to 300. They tell us there's the population proportion, there's the other one. So we need to work out the z. Okay, that's interesting. So I need to get to that one. So it's p minus the, before I do it the other way around, so p minus that, because you will see one is negative, one is positive, so it will be one of those two probably that is the answer, and then it is divided by 0. So let's first write it out, but it's nearly the whole time the same formulas that we use. It also nearly sticks in your mind. So 0.35 minus 0.4. So I know my answer is going to be a negative, because it's going to be 0.35 minus that is going to be minus 0.5. So without even going further, I would have automatically said that is my answer. Okay, because that's the only one that has a negative. But if they have given you another negative, let's work it out quickly. So it is 0.4 times 1 minus 0.4 is 0.6. So 0.4 times 0.6 gives me 0.24 divided by n, which is 300. That gives me 0,0008. So if I take the square root of that, I get 0,0283. So if I then say 0,05 divided by 0,283, and remember the negative, I do get my answer as negative 1.7678. Okay, so obviously 76. Okay, so maybe I now made a mistake in my division, which can also be and if I round it off to, okay, sorry, 0, it is 1.7668. Okay, which is that option. Okay, but again, nearly trying to show you, in a sense, a shortcut. I've seen there's nearly those two, so I nearly always look at it and say, okay, well, if you give me a positive and a negative, I want to choose normally between the two of them. Because it was negative, you can nearly automatically go to that one unless there was another negative. So it could have been that they give you that one as a negative as well, and then you need to go through the whole process. Okay, but here they give you everything and you need to basically calculate the Z. Okay, so let's look at another standard error. Okay, so a lot of standard errors in this one. So random sample, I tell you what the proportion is. So 0.2 times 0.8, because it's 1 minus 0.2 divided by the 85 and the square root of that. So let's quickly see. If I say 0.2 times 0.8, I get 0,16, so there wasn't at least that. If I say divided by 85, I get 0,0019, which was the option, but then I need to take the square root of that, and that gives me 0,0434, which is option 2. Okay, so again, if you didn't do the square root, there was an option for you already. Okay, so just to once again show that they nearly have that as well. Okay, unfortunately. I don't know how they did that, but that's maybe if you even go further to work out a probability or something like that. Maybe that comes up. Okay. Okay, so the last one on this, and then another. Okay, so I randomly just selected a few, and it's funny how it was all a lot of the the standard errors. So let's just look at this. A random sample of 50 households was selected for a telephone survey. The key question asked was, do you or any member of your household own a a cellular telephone with a built-in camera? Of the 50 respondents, 15 said yes and 35 said no. Okay, so 15 said yes that they have a built-in, 35 said no that they don't have a built-in. Okay, so so that is why they want to now check if you do it correctly. So what is the population standard error of household with a cellular telephone with a built-in camera? Okay, so basically when we look at the standard error, it is the 15 divided by the 50. So let's just get a decimal for that. $15 divided by 50. Does that give me 0.3? Okay, that is weird. Okay, 0.3. Okay, so automatically you see that when you worked out the proportion, it was already flagging as one of the answers. Okay, so 0.3 times 1 minus 0.3 is 0.7 divided by the sample of 50, and let's take the square root of that. So 0.3 times 0.7 gives me 0.21 divided by 50 gives me 0.0042, which again is an option, but remember we need to square root, and that will then give us 0.0648, which is option 3. So again, you nearly get those two. If you used the not built in, that was 0.7. So there was the 0.7. But what is interesting is if you use 0.7, that would have been then 0.7. That would have been 0.3. So in the end, your answer would have been exactly the same. So that just is because you are working with the proportion, that just is how it works, because here you used the proportion of the built-in, and there you used the proportion of 1 minus the built-in, which is actually the not built-in. So if you calculated the population standard error of the not built-in, you will actually get the same answer. The only difference is that the P that you would have used as the original, you would have said 0.7, but because you on the other side is going to minus the 0.7, 1 minus it, you're actually working with the same numbers. Okay, so if you said in this one the other way around, your standard error, you would have still gotten the same answer. Okay, so that is basically looking at study unit 7 with the sampling distribution. So looking at the sampling distribution of the mean, sampling distribution of a proportion, how to work out the Z when we had the mean, how to work out the Z when we have a proportion, and if I ask you to work out the standard error, how to work out those two as well. So the next session, when I'll schedule that, we'll look at study unit 8. Yeah, so just keep your calendars, keep a watch out on that, and I'll also communicate on the WhatsApp group when the next study unit will be. Okay, great everyone. Have a good evening. Let me just stop the recording as well. I'll ask Rian again to